Perfect. So coterminal angles are going to be very similar kind of in nature to our reference angles. The reference angles, though, if you notice, whenever we were working with our reference angles, we were looking at one of the other three quadrants, right? And we were referencing everything back to the first quadrant. Well, coterminal angles are going to be angles that are bigger than 360, or maybe they're smaller than 0. And by smaller than 0, we're saying, hey, they go into the negatives. And so what we're going to do is we're going to find coterminal angles. So we're going to find angles that we can use to help represent these bigger than 360 or smaller than 0 angles. And then we're going to evaluate and find the reference angle and the trig function for each of them, okay? So just kind of as we're going through this, just so you know, I do have another short quiz for you. If you notice, my quiz have been kind of short, like 20 minutes here. Just kind of checking, seeing how you're doing. So your next one is on Thursday when y'all come back. Yeah, I know you're just going back, but Thursday. And it's over reference angles and coterminal angles. So what that assignment that you just checked, and then the one that we're going to go over today, okay? And I think you'll find that today's hopefully not too bad. All right, so when we talk about coterminal angles, we're talking about angles that have the same starting and ending sides. And we call those the initial and terminal sides. And so they're called coterminal because they have the same terminal side. And what does terminal mean? Like, what's the meaning of terminal? Ending. They have the same ending spot. So for example, I'm just going to draw an angle on here. Let's say we have a 45-degree angle. That would run from the positive x-axis and up, right? 45. Well, it's possible to have an angle that starts here, goes all the way around the circle, makes a full 360, and then comes back up to the 45. And that has the same starting and ending spots. Now, that angle is not 45. It's actually 45 plus 360. So that angle would be what, 405? So if I give you a 405 and ask you to find the sine or the cosine or the tangent, 405 is going to behave like 45 because it has the same start and ending spot. So it'll have the same sine, cosine, tangent, all that fun stuff. So what we're going to do today is we're going to work with these angles that maybe go around the circle once, or maybe they go around the circle twice, or maybe they go backwards around the circle. And we're going to go ahead and figure out what angles we can use to find their values, okay? Their trig functions. You ready? So if you're looking for a coterminal angle, you can add or subtract a full circle. And a first circle is how many degrees? 360. You can do that more than once because if it goes around the circle twice before it stops, then you'd have to subtract 360 twice to get back in the right area. If it's in radians, what's the equivalent of 360 in radians? 2 pi. So you can add or subtract 2 pi for your radians. For any given angle, there are infinitely many coterminal angles because you can always go around the circle one more time, right? You can always add another 360. Add another 360, add another 360, and you can end up with infinitely many coterminal angles. So we could say, all right, 45 is coterminal with 405. We could add 360 and get another one, add 360, and just keep adding 360 and taking extra journeys around the circle. Okay, so we're going to start by finding the coterminal angles between 0 and 360 for each of the following. So 405, oh man, I just did that one. So 405 is bigger than 360, right? So if you take off 360, a full rotation around the circle, you'll be left with 45 degrees. So if I ask you for the sine of 405, you can tell me the sine of 45, and they'll be the same value. All right, what about 525? That is bigger than 360, right? So you can subtract off 360. What is 525 minus 360? One what? 165. Now, I know that's not an actual angle that is on our unit circle. It's on there. It's just not like one of the nice ones that we use. But if I asked you anything about 525, you could use 165 in its place. All right, the next one is negative 120. Do you know what happens to get a negative angle instead of a positive angle? You're going to have to add 360. So what's happening with the negatives, let me draw you a picture up here. is we always start here at the positive x-axis, right? Instead of going this way, counterclockwise around the circle, we are going clockwise around the circle. So that would be a negative 120. You just go the other direction. So if you want an angle between 0 and 360, if you add 360 in this case, that'll get us 240. And so if you think about the positive 240 is the same as the negative 120. Negative just happens to go the other direction. All right, 270. If you want to get an angle between 0 and 360, we would have to add in this case, and we get 90. So negative 270 is the same as a 90-degree angle. All right, up next, 1020. And so what do you know about 1020? Think about the number 1020. 1020 degrees. Has it gone around the circle once? It's gone around twice, right? Twice plus a little extra. So you can subtract 360 and then subtract 360, or you can subtract 720. So you can kind of help yourself out by knowing the 360s, how many times 360 around is. So 360, right, is one time around. 720 is two times around. What would be three times around? 1080. And then if you wanted to keep going, you could add another 360. So you don't have to just add a 360. If you know automatically that it goes around more than once, you can go ahead and add or subtract more than that. All right, so 1020 minus 720 is 300. All right, I'm going to let you finish the last three, and then y'all can just tell me what you got. So finish them, last three, then we'll talk radians. All right, for this second one in the second row, 684, what did you get when you subtracted 360? To what? 288? 288. And then negative 750. What did you end up adding in this case? Yeah, 1080. If you add 360, you're still in the negatives. If you add 720, which is 360 twice, you're still in the negatives. So you can go ahead and just add 1080 to this one, saying, hey, you got to go around three times before you end up in that positive. And when you add 1080, what do we get? 330. All right. And then last but not least, negative 600. What did you add for that one? 720. And we ended up at 120. Perfect. All right. Do you have any questions about coterminal angles for degrees? When they're in degrees, add, subtract 360 accordingly. Okay, so now we're going to talk radians. And the thing with radians is they're always just a little bit harder, right? And why are they a little bit harder? Because they are fractions. They have this pi in them as well, but don't let the pi get you down, right? Because it's really just a fraction. So if you think about 22 over 6, yes, there's a pi, but just think about 22 over 6. Is that more than 2 pi or is it less than 2 pi? Like, where does that number fall? It's more than 2 pi. How do you know that it's more than 2 pi?
Because it's more than 12.
Because it's more than 12 over 6. And 12 over 6 simplifies to 2 pi, right? So if it's more than 2 pi, then you can subtract 2 pi. And we're going to subtract 2 pi, but we're subtracting it in the form of 12 over 6. So subtract 12 pi over 6. And that gives us
10 over 6 pi.
10 pi over 6, which then simplifies, doesn't it? 10 over 6 simplifies to 5 pi over 3. So if I ask you to find like the tangent of 22 pi over 6, you could just tell me the tangent of 5 pi over 3. So you're going to be able to add or subtract 2 pi, but you're going to change 2 pi into the fraction so that it has the same denominator, because you're add or subtracting, you need to have common denominators. Now look at the next one. The next one is 24 pi. And so 24 pi is a bunch of 2 pi's, isn't it? Right? How many 2 pi's is in 24 pi? 12. So you could think about this as 12 times 2 pi, right? So that means that it's gone around the circle 12 times. When it goes around 12 times, where does it end?
0.
It ends at 0, right? It ends at 0. So 24 pi is the same as 0.
It ends for an angle between 0.
Say it again?
Is this like greater than or equal to and less than or equal to? Or is this?
Yeah, for this one, because I didn't actually denote which one, you could say 0 or 2 pi.
All right.
Yeah, that would be fine. I would take both in this case. All right, negative 5 pi over 3. Well, for starters, it's negative, so automatically we know that we're going to have to add, right? So we need to add 2 pi, but the equivalent of 2 pi with an over 3. So what number goes on the top?
6 pi.
6 pi over 3, because 6 over 3 is 2. All right, and then add those together, we'll end up with pi over 3. So if I ask you anything about negative 5 pi over 3, you can tell me all the information dealing with pi over 3, and it will all be the same. All right, the next one, negative 31 pi over 4. Definitely in the negatives, right? So we can add. What should we add here?
32 pi over.
Ooh, 32 pi over 4. Now, what is 32 over 4? 8. So technically, we're adding 8 pi. So we added 2 pi, another 2 pi, another 2 pi, and one more 2 pi. So as long as you add 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, some even amounts of pi, then technically you're just doing your full circles, right? This is 1 time around, 2 times around, 3 times around, 4 times around, 5 times around. So you can add any combination of that. So we went straight to 8 pi because we needed the numerator to get out of the negatives, right? So that's going to be what, pi over 4? So negative 31 pi over 4 is the same angle as pi over 4. It just goes around the circle a bunch of different times. 4 times to be exact, right? All right, I'm going to let you finish that entire bottom row. Give it a shot. Let's see what you come up with. And see if you can get those coterminal angles. All right, that first one, 22 pi over 3, you end up having to subtract, right? How many pi's over 3 did you subtract? 18? 18 over 3 is 6, so that means you subtracted 3 full rounds, right? 3 full rounds. And so 22 minus 18 is 4 pi over 3, and 4 pi over 3 is less than 2 pi, so you're good to go there. On the second one, how many pi over 3's did you add? 6. You just needed to go one time, right? It was just barely in the negatives. So if you add that, you have 5 pi over 3. All right, the negative 43 pi, what'd you end up doing here?
Plus 44.
Plus 44 pi. 44 is even, right? So it went around technically 22 times. You went back around 22 times and ended up with just a pi, right? Just a pi there. And then the last one, negative 19 pi over 6. How many pi's did you add? 24. So 24 over 6 was 4 pi. So technically you added 2 full rotations back and ended up with 5 pi over 6. All right, what do you think about those radians? Yes, no, baby? All right, so before we get in to finding sines, cosine, tangents of all this, I wanted to kind of like just take a moment and talk about something slightly different, and then we'll go right back into it, okay? So we're going to talk about complementary and supplementary. How many of you have heard of these two things before? That should be everybody, because you're talking about them in geometry part A to be exact. Do you remember what they are? Complementary angles and supplementary angles?
One is when it adds up to 360 degrees.
Ah, super close. They add up to something, but it's not 360. What was that? 180. One of them is they add up to 180. The other one is adding up to 90. So one of these adds up to 90. The other one adds up to 180. And so do you remember which one's which?
Complementary is 180 and supplementary is 90.
Nope. But you had a 50-50 shot, right? So here's how I remember. Those are the first 3 letters of each one, right? If you take the CO in complementary and draw a line going down, complementary makes a 90. And with a little creativity here, you can turn that into a 180. So supplementary add up to 180, complementary add up to 90. So complementary 90, supplementary would be 180. If it's not in degrees, if it's in radians, 90 degrees in radians is going to be pi over 2. And then 180 in radians is pi. So if we're looking at the radian ones down here, we'll have to go to pi over 2 and pi. All right, so when you do this, just make sure you label like complementary, right? And then supplementary so you know which one's which. So if you have a 45-degree angle, what is a complementary angle to it? 45, because 45 plus 45 is 90. If you have a supplementary angle to 45, that's going to be 135, because 45 plus 135 is 180. All right, complementary to 60. 30. Supplementary to 60. 120. Adds up to 90, adds up to 180. All right, complementary to 120.
Wait, negative 30?
Complementary would technically be negative 30, or you can go ahead and say that there's no complementary angles, because if you add a negative 30, technically you're subtracting, right? So I'm okay if you say negative 30, but I'm also okay if you say none, because it's too big. But just because it doesn't have a complementary angle does not mean that it doesn't have a supplementary angle, right? Supplementary would be 60. And last but not least, 225, its complementary angle.
Negative 135.
Yeah, you can say what? Negative 135, or you can just go ahead and say none. And supplementary. Also none, or you could say negative 45, right? Either one is fine. I think technically it's supposed to be none, technically, but if you give me the negatives, then obviously you know what you're doing still, right? All right, so same thing, but now we're talking pi over 6 in radians. You ready? Complementary means that they add up to 90, but if we're in radians, technically pi over 2. Now, if I'm looking at a pi over 6, I should think about pi over 2 as something over 6. What number over 6? 3 over 6 is 1/2, right? Pi over 2. So what do I need to add from pi over 6 to get 3 pi over 6? So this complementary angle is 2 pi over 6, which does actually simplify to 1 over 3. So pi over 3. And then you can do literally the exact same thing with your supplementary angles. But in terms of supplementary, it doesn't add up to pi over 2, it adds up to pi. And so in terms of over 6, pi is going to be 6 over 6, right? So what do we have to add to 1 over 6 to get 6 over 6? 5 pi over 6. So a little bit more difficult with the radians, but as long as you know how to work with those fractions, you just change your denominators accordingly, right? All right, pi over 4. It's complementary angle that will make it pi over 2. Add up to pi over 2. Also pi over 4. You could think about this as 2 over 4, right? And if you have 1 over 4 and another 1 over 4, then you're going to get 2 over 4. And then its supplementary angle will be 3 pi over 4, because that's how you're going to get 4 over 4, which is equal to pi. All right, 2 pi over 3, complementary angle. Yeah, there's none, because 2 over 3 is bigger than 1 over 2, right? This is when it's really easy to just say none and not worry about the negatives. All right, supplementary angle is
none.
Close, pi over 3, because we're just trying to get to pi, right? And 2 pi over 3 is not quite yet.
I had already
3 over 3.
The next one.
Oh, you're just ahead of us. That's all right. That happens too. Sometimes somebody will say something random and people like look at them and be like, no. They're like 3 steps ahead of me. They're not wrong. They're just ahead of the game. All right, pi over 2. Complementary angle to pi over 2. Technically, you can say 0, right? 0 is, you would add 0 and that would still be, yeah. It's not technically a subtraction, so I would go with 0 in this case. If you said none, I would give it to you as well. All right, and supplementary to pi over 2 is also pi over 2, because 1/2 and 1/2 will make the whole pi that we need for them to be supplementary. So kind of got sidetracked a little bit on the complementary, supplementary angles. Nothing too crazy there. I will let you know that there's no additional homework practice on those, and it's not on your quiz on Thursday, okay? So just kind of FYI, just like a little side note info. So we're going to go back to coterminal, and we're going to evaluate these trig functions. And we are going to do it without the full use of the unit circle, right? Because that is our goal now. You've already showed that you can memorize the whole thing, but I don't want you to take 20 minutes every time we have a quiz or a test to make the whole thing from memory every single time. So moving forward, the goal is to know reference angles, because reference angles, you only have to have the first quadrant, okay? All right, so if you get really good, you don't even have to write the first quadrant down, right? Remember, you can use the hand trick to kind of visualize what's going on in the first quadrant. And so I'm not going to write a whole lot on the board. I have the unit circles over there. Just don't look at it. Okay? Pretend like it doesn't exist. All right, sine of 660. So 660 is bigger than 360, right? So the first thing we have to do is we have to get a coterminal angle. So we have to get an angle that starts and ends at the same spot for us to compare this to. So what are we going to do? Subtract 360. And so we can look at the sine of 300. These two values will be equal. Whatever sine of 660 is, sine of 300 is exactly the same. Now, 300 is not in the first quadrant, is it? No. What quadrant is it in? The fourth quadrant. Is sine positive or negative in the fourth quadrant? It is negative. And if you need to make yourself a little chart, right? In the first quadrant, what's happening? I'll write it over here. What's positive in the first quadrant? Everything, right? They're all positive. In the second quadrant, sine is positive, which also implies that cosecant is positive, right? And in the third quadrant, tangent, so it's reciprocal cotangent. And then fourth quadrant, cosine and secant are positive. That, you could jot that down at like the top of your quiz. That wouldn't take too long, right? To kind of throw that information up there. All right, so 300 Q4, sine is negative in Q4. So what's our reference angle for 300? Of 60, right? So we're going to reference 60 degrees. And so this is where knowing it, either writing it down, that first quadrant, or knowing it is super helpful. So I'm going to use my hands, all right? 60, it goes 30, 45, 60, right? In order. So 60 is this one. Cosine and sine. So sine is square root of 3 over 2. So our sine of 660 is negative square root of 3 over 2. So we combined coterminal angles and reference angles to get that value there. All right, cosecant of 585. So we need a coterminal angle. So subtract 360. What do we get? 225. So we can use the cosecant of 225 instead to evaluate this. And 225 is in what quadrant? The third. Is cosecant positive or negative in the third quadrant? It is negative. And then what angle are we going to reference? A 45-degree angle. And so if you think about your little hand thing, right, 45 is the one in the middle. And then cosecant is the reciprocal of sine, right? So you have cosine and sine. So it's a reciprocal of square root of 2 over 2, which is just the square root of 2. So here's where knowing your reciprocals comes in handy, right? Then you don't have to think about them or write them down or any of that fun stuff. All right, cotangent, negative 945. So we're going to reference a cotangent of a coterminal angle. So what do I have to do to get this to a coterminal angle? I'm going to have to add for sure. How much should I add? 1080. Yeah, 1080 will get it back into the positives. You could add 360, add 360, add 360 until you get there. Or you can just be like, I'm just going to go straight to the 1080. So if you add 1080, what do you end up with? 135? All right, so cotangent of 135. Will 135 be positive or negative for cotangent? Negative. It's in Q2, right? And cotangent is negative in Q2. All right, and then what's the reference angle? A 45-degree angle. And so if you think about your little hand trick again, right? 45 in the middle. Cotangent is cosine over sine. Well, on 45, they're exactly the same. So when you divide them, you'll get 1.
This is just what we did earlier with one extra step.
Yes. So we've done the coterminal part, right? This part, figuring out a coterminal angle. And we've done the reference, which is what you did, but that was your homework, right? So now you're on that kind of one additional step of putting those two ideas together. All right, sine of 840. Going to take off how much? I would take off 720, which is 360 times 2, and end up with sine of 120. And is the sine of 120 positive or negative? This one is positive, right? 120 is in Q2, and sine is positive. So you can put the positive on your paper. That's completely fine. Or you can just leave it off there. And then 120, what angle do we reference? 60. And so if you pull out your little hand trick again, it goes 30, 45, 60, right, in order. So if I put that one down, sine is the second one. So cosine, sine. So square root of 3 over 2. All right. Are there 2 more degrees on here, I think? Yeah, do the next 2, 5 and 6 on your own. Give them a shot. See what you come up with. All right, number 5. What's a coterminal angle? What'd you end up adding to get this coterminal angle? Add 720. When you add 720, you ended up with secant of 30. Now, the really nice thing is you don't need a reference angle for 30, right? So you kind of get to skip that whole second part. So now you're just on secant of 30. That's in Q1, so it's going to be positive automatically. 30 degrees is this one, right? And so secant is the reciprocal of cosine. So the reciprocal of square root of 3 over 2. So 2 over the square root of 3. Rationalize 2 square root of 3 over 3. All right, and cosine of 720, what did you pick for a coterminal angle? Cosine of 0. Yeah, if you subtract 720, you end up with 0. You could have subtracted 360 and said cosine of 360 as well, right? Both of those would have been fine. And really, it doesn't matter because you're going to get the same value. So what's the cosine of 0? 1, yeah. Whenever you're looking at one of the 4 quadrantal angles, those are the ones that are on the actual axes, the x and the y's, you don't need to worry about referencing anything. Just use the angle itself, okay? If you try to reference it, it'll just make a hot mess, and then you'll get confused. And just know, right, positive 1, negative 1, positive 1, negative 1 for x's and y's. All right, now let's do the same thing, but we're moving on to some radians. So cosecant 13 pi over 6, that is more than 2 pi. So that is not currently on my unit circle in one rotation. So we got to get it back. So what do we need to do with 13 pi over 6? You're going to have to subtract, right? You're going to have to subtract something pi over 6. Know that immediately. So how many pi's over 6? 12, because 12 pi over 6 is the same as 2 pi. So that'll give us the cosecant of pi over 6. And pi over 6 is in the first quadrant, so we don't have to reference anything. We can just go ahead and say what this value is. Pi over 6, so it's pi over 6, pi over 4, pi over 3. They go in order from smallest to largest in terms of the fraction, right? Over 6 is smaller than over 4 is smaller than over 3. So it's this one. Cosecant is the reciprocal of sine. So sine is the 1/2. And so the reciprocal of 1/2 is just 2. All right, cotangent 9 pi over 4, not on the unit circle in that first rotation, so we're going to have to get it there. So I'm going to have to subtract something over 4. 8 pi over 4, right? 8 over 4 is 2. So we're just subtracting a fancy version of 2 pi. So cotangent, when you subtract, you'll get just 1 pi over 4. And once again, you don't need to reference anything, right? Because pi over 4 is in that first quadrant. Pi over 4, that's where sine and cosine are the same. So any tangent cotangent is equal to 1. All right, tangent 19 pi over 4. Automatically, by the way, without looking at this, it's either 1 or negative 1, isn't it? Because if it's over 4, no matter what happens, it's still going to be over 4. We're going to reference pi over 4, and it's either 1 or negative 1, depending on what quadrant this is in. All right, we do have to take off something over 4, though, right? How many over 4s? 16. So you could take off 8 over 4, but that wouldn't get you down into the 2 pi range, right? So you'd have to take it off again. So you can just go ahead and take off 4 pi, which is 16 over 4. So this would be the tangent of 3 pi over 4. And 3 pi over 4 is positive or negative for tangent? Negative, because this is in Q2, and tangent is negative in Q2. And since it's 3 pi over 4, we're referencing pi over 4, right? And we already said that tangent of pi over 4 is equal to 1 because that sine and cosine are the same. So you might find a coterminal angle and then have to use a reference angle, or you might just have to use a reference angle, or you might have to just use a coterminal angle to get you in the right spot. All right, cotangent. Negative 23 pi over 4. Automatically, I know it's either 1 or negative 1, right? For the exact same reason as the last problem, so this is kind of boring, but that's okay. So we're going to have to add, because this is in the negatives, something pi over 4. 24. 24 over 4 is 6. So as long as you're adding an even number of pi's, you're good. So this will be cotangent of just pi over 4, right? So no reference or nothing. And cotangent of pi over 4 is equal to 1. Sorry, those were all kind of boring and the same. All right, I'm going to let you do these last two on your own. See how they go, and then we'll check them. Is anybody need more time on them? Are we good? All right, so what did you get for the tangent of negative 11 pi over 2 for your final answer? What'd you get? Undefined? Anybody else undefined? Yes? And so you had a coterminal angle, a tangent of, what was the coterminal? Pi over 2. So you added 12 over 2, 12 pi over 2. And so at pi over 2, that's the angle that's up here, right? It's a quadrantal angle. So you don't have to reference anything. You just know cosine and sine, and tangent is sine divided by cosine. So it's 1 over 0, which is undefined. All right, and then what did you get for your final answer for number 12? Negative square root of 3 over 3? Anybody else? Negative square root of 3 over 3? Okay, so this was cotangent of what angle was your coterminal? 2 pi over 3? Because you ended up adding 12 pi over 3, right? So you ended up adding 4 pi. And then you had to reference pi over 3. And so if you used your hand and reference pi over 3, cotangent is cosine over sine. And so your square root of 3 ends up in the middle of that fraction. So that's why it's square root of 3 over 3. And in Q2, it is a negative. All right, so your homework assignment is the next 2 pages, and you have quite a bit of time to go ahead and start on it in class. You might even finish it, which is fine. In terms of as you're working on that homework assignment, don't look at the unit circle. I'm going to erase this. If you want this, write it at the top of your paper, right? Write whatever you want at the top of your paper. If you can do this homework assignment, then the quiz should go just fine for you, okay? If you can't do it, quiz might not go so hot. So there might be some things that you need to memorize or kind of pick up on some patterns for. Also, quiz will be timed, right? Kind of like the unit circle. I'm not going to give you all block to do it. And no calculator, no notes, no nothing. I'm going to rip that off the wall, all right? So everybody's on the same page? Cool.